In this video, we find the maximum area of the trapezium with sides of length 1, 2, 3, and 4. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. So when we're given the trapezium, then there are two possible cases for such quadrilateral. The first case would be just having one pair of parallel sides, something like this. Not a terribly nice drawing. Or it can be a special case, which is having two pairs of parallel sides. So in that case, we're having something like this. That's what we call the parallelogram. But for a parallelogram, apart from two pairs of parallel sides, we need the opposite sides to be equal as well. So that's impossible because the sides have length to be all distinct for the quadrilateral we are given. So we can just rule out parallelogram case and stick to the usual one, which is that there are only one pair of parallel sides and the other pair is not parallel. So now I'm going to label the sides as A, B for the sides that are parallel to each other, and the other two sides to be C and D. And in particular, I'm going to specify that by saying A is less than B and C is less than D. And in fact, we do not have many possibilities for that. Like A and B can be like 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. Then from this, we can say that C and D are 3, 4, 2, 4, 2, 3, 1, 4, 1, 3, and 1, 2 respectively. Now what will happen if we have the sides to behave like that? Then we can actually construct a parallelogram and a triangle inside the trapezium. I'm going to split it into two parts. The first part is a parallelogram. Side lengths of this blue dotted line will be C, and the base will be A again. And for the third side of the new triangle, small triangle, will be B minus A. So let's see what the values of B minus A are for respective cases. For B minus A, it can be 1, 2, 3 for these three cases, and then 1, 2, 1 again. Now notice that CDB minus A block has to be a triangle, and thus the side lengths have to satisfy the triangle inequality. Now, however, there's only one case among these 6 that satisfies the triangle inequality, because for the first case, 1 plus 3 equals 4, so it's a no. And then 2 plus 2 equals 4, it's a no again. We just add them two shorter sides and compare the longest one. But the third case is okay because 2 plus 3 is larger than 3, so we are good. Next, we have 1 plus 1 to be not even equal, but less than 4. So it's definitely a no. 1 plus 2 equals 3, so it's a no. And for 1 plus 1 equals 2, again a no. So that means we only have this case, having the top side to be 1 and the bottom side to be 4, and then the two other sides to be 2 and 3. We can only arrange the sides in that way. so a trapezium can be possibly be formed. So that means our trapezium should look like this. One, 4 for the top and the bottom, and then 2, 3 at the sides. Now it remains to find the area for this trapezium. Again, we can go back to the parallelogram and the triangle. So the first I'm going to find is the area of the triangle, which has side lengths 2, 3, and 3. I'm going to use the Heron's formula. The semi-perimeter is 4, 2 plus 3 plus 3 halved, and then so it's 4. So area equals to the square root of 4 times 4 minus 2 times 4 minus 3 times 4 minus 3. And that is 2 times square root of 2. So that's the area of the triangle. Now, for the parallelogram at the side, we need to find the so-called height. Say this one. But we do not have that yet. So we're going to make use the triangle again to find the length of the red dotted line. So let h be the length of that dotted line. Then we know that 3 times h over 2 equals 2 times root 2. So h becomes 4 times root 2 over 3. So therefore, our final answer, the total area, is 2 root 2, the area of the triangle, plus 1 times h, which is 4 times root 2 over 3. And you simplify that, and our final answer is 10 times root 2 over 3.